Welcome to Q-square approach. In this video, we'll see an infeasible solution of the linear programming problem. If the given constraints are not satisfied simultaneously, then the solution is called an infeasible solution. It means the convex region or solution space or feasible region will not exist for the given constraints. Now, let us see the problem. The problem is maximize z is equal to x1 plus x2 subject to the constraints x1 plus x2 less than or equal to 1 minus 3x1 plus x2 greater than or equal to 3 and x1 x2 both are greater than or equal to 0. From the first constraint we have x1 plus x2 is equal to 1. In this equation, if we give x1 is equal to 0, then we'll have x2 is equal to 1. That is 0, 1. If we give x2 is equal to 0, then we'll have x1 is equal to 1. So the points are 1, 0. Now I'll take the second constraint, and then we have minus 3x1 plus x2 is equal to 3. If we give x1 is equal to 0 in this equation, then we'll have x2 is equal to 3. So the point is 0, 3. If we give x2 is equal to 0 in the same equation, then we'll have minus 3x1 which is equal to 3, which implies x1 is equal to minus 1. So the point is minus 1, 0. Now we will draw the graph. We'll take it as x1 axis and this x2 axis, and this the origin. So the points are 1, 2, 3, 4. Here 1, 2, 3, 4, and here minus 1, minus 2, here minus 1, minus 2. Now the points for the first constraint are 0, 1 and 1, 0. So 0, 1 is here. So 0, 1 and 1, 0 is here. So 1, 0. Now we'll join these 2 points by the straight line. The name of this line is x1 plus x2 less than or equal to 1. And from the second constraint we have the points 0, 3 and minus 1, 0. 0, 3 is here, 0, 3 and minus 1, 0 is here, minus 1, 0. Now we will join these 2 points by a straight line. and the name of this line is minus 3x1 plus x2 greater than or equal to 3. Now we start to set the region in the constraint x1 plus x2 less than or equal to 1. In this constraint we have less than or equal to, so we have to set the region towards the origin from this line. So from this line towards the origin from this line, and in this constraint we have greater than or equal to, so we have to set the region in the opposite direction to the origin from this line. So opposite direction to the origin like this. Now if you observe the graph, there is no common region, common shaded region for the both constraints. Hence, there is no feasible region for the given problem. Hence, there is no feasible region for the given constraints. That's why the given problem has an infeasible solution. Thank you for watching.